Hey there, my name is Michael Millerud, and I'm a product manager on the Azure Application Insights. Today, I want to take you through a journey of how to find and diagnose performance issues with Azure applications using AI, Application Insights. I know it's a mouthful of the title, but this story is very exciting to me personally because I spent the past decade building the necessary infrastructure and foundation, sort of searching for this experience. And it took me all the way from operating systems through Power BI and into the Azure universe to be able to build this at scale so you can easily look at the last 30, 60 days of data across geo-regions, across roles and instances, and quickly triage and identify and diagnose performance issues. So let's get started. I've been with the team for about 2 years now and primarily focused my attention on the APM aspect of it, which is the application performance management. The problem is that most of this used to be data-driven, and application insights should really be all about insights. It's in the title. It's the second word. So let me show you what I mean. When we GA'd Application Insights a year ago, it was a traditional bladed Azure experience. So you would see in the performance blade, for instance, your trend for operations and the slow operations. You would click and you would dive deeper into more data, and people would start getting lost. There's just too much data, too many blades, and how it all connects together. And worst, even if you clicked on the left, the blades on the right would disappear. It wasn't really leading you anywhere good. It was just showing you more and more data. We did show you some insights, and it didn't ship it GA, we shipped it afterwards, but we tried sort of to improve and add some insights to this experience. But they were kind of an afterthought, and they were not really designed in from the get-go. So what we did instead with the APM v2 is to start from scratch. And instead of doing all this bladed data squared problem, we gave you something that is interactive. Wouldn't it be nice if you could just click around, and as I select different operations, I get to see how they trend over time and how often they become slow and what kind of insights the system can actually tell me about them. And that is exactly what I will show you today. So this is a typical triage view. It's a full screen portal view. Unlike the previous bladed experience, there is only one place for you to look at for triage. And the insights, as you can see, are right in front of you, and they're always going to be present as you explore your data. We have carded insights, such as these, and we also have these visual, interactive, rich graphs, such as the duration distribution, where you can go and see just how often your particular operation of interest was slow, and just how slow. You can also see through the profile traces above where you actually went and collected profile traces. This will be important when you go and diagnose the issue. Of course, everything here is interactive, so as I start selecting different time regions, the roles I care about, whether I want to look at averages on the 95th percentile, it will all just switch in place. You don't have to open more and more blades. And that's very, very effective for not losing focus of what you're actually looking at. You can also zoom in and just look at the slow requests, for instance, right? Previously, you would get a flat, long list of issues to look at, and you would have to go and search for them. Now it's all one. You can easily go and zoom in on the right things before you dive deeper. So the triage is much, much faster. We've also given you an action button. So one of the feedback items we used to get from our customers is that we keep clicking, and we see more and more data, but we don't know where this all leads. What should we do about it? And it used to end up in a sort of a dead-end scenario where people will sort of get towards a details blade, but didn't really know whether that was a big issue or not and what to do about it. Instead, the triage view lets you zoom in and filter temporally and in frequency just to the right places in the dataset, and then you can take action and dive in whether to look at samples that represent that or the profile traces that actually tell you what the code is doing behind the scenes. So in a summary, what we did is we moved from this bladed data squared universe of data-centric APM into the full screen data plus actionable interactive insights universe. The data is always there. It's always supported by insights. In fact, we ask you to start from insights first, and then, guided by insights, look at the data. There are other things we did as far as improving the mechanics and the usability of the experience. For instance, in the previous version, for you to get to the details of a single request, you had to do 1, 2, 3 clicks, diving deeper and deeper into the data before you could see that single operation. And that shouldn't be that hard, right? I mean, I should be able to see a given slow request very quickly. So what we did in APM v2 is the list of requests is right built into the APM triage view. As you click, the blade just opens up. It's a single click. It's really, really easy to get to. The service profiler integration is something we actually shipped last year, but it was kind of a link to a separate service. And this is where I'm sort of transitioning from triage into diagnostics. For me to actually go and look at the code, you need to be able to collect those performance traces I mentioned before. And we used to have these buttons at the first blade, which would open up a separate service called Service Profiler. We can go and look at all the traces collected for that particular operation. Problem was there were lots of traces, sometimes very many traces. In this case, it's quite a limited number, but in practice, you could see thousands of them, hundreds of them. So instead, what we did is we did a very deep integration with Profiler for V2. So as you click on the button, it will open up just the traces that correspond to whatever you filtered to. As you see in the duration distribution, there are 3 different triangles to the top, and that shows you where we have collected Profiler examples, the traces, that went and measured this experience. Now remember, this is not a basic failure crash dump. It actually takes a while to collect a trace in production. You have to start, collect it over time, stop, compress, send it over. All of this magic is happening behind the doors. You don't have to even think about it. As soon as you enable Profiler, it starts collecting, and over time you start seeing these triangles show up over your duration distribution. And as you do, you can go and actually answer the question not only of if it's happening, but also why it's happening. So let's actually go and do a demo of this. So it's not just screenshots, but actual real-life production code. So let's start our journey by looking at an application called Fabric and Prod, which is an app service running in Azure. This is your Azure dashboard that we created for that application. And now I'm opening the Application Insights blade and switching to the performance view. This is the triage view that you've seen screenshots of. As you can see, I can look at different operations of this application. And right now it's sorted by the duration average. So I'm going to switch this to the 95th percentile. And I'm also going to sort by count, so I can see my most commonly used operations. As I click through these operations, I will see the different insights and the trends and the duration distributions specific for that operation. It's all very, very interactive. So let's focus our attention on one of them. In this case, get home index seems to be of interest because there's quite a few of them and I see some spikes, right? Let's look at a bigger time range. How about 3 days? What I see is that in the 95th percentiles, sometimes it's around 700 milliseconds and then sometimes it goes up to 1.2 seconds. So zooming in around 99th percentile and zooming in some more. So I actually capture my 95th to 99th 4% range. I see my data is updated so that it says now that this is United Kingdom that's spending 80% of requests being slow. Now, if I go and zoom out again, it will not tell me United Kingdom. In fact, it tells Wilmington, United States, Delaware. And if I zoomed in around my biggest spike, it still says Wilmington. So what that tells me is that this is region specific and United Kingdom has experienced a slowdown. While elsewhere in the world, this was actually pretty fast and most of the users came from Texas. And that's valuable, but that only gives me the triage. I also want to know why this is slow, right? I could look at what are my top 3 dependencies, the blob, the queue, and the SQL, and how long they take. And that actually seems to contribute to most of this. 95th percentile, 1.3 seconds, is right about where I am right now. So chances are this is dependency. But I could actually go and dive deeper into this with the profiler. And I see that I have a really great coverage of profiler traces in this case. So I can just go and click on this profiler traces, 6. That means there are 6 of them collected. And this will open the diagnostic full screen view for me. Like I mentioned before, Profile is now deeply integrated into AI. It's essentially AI Profile. It's not a separate service. And what I see here is a range of different experiences that we took traces for. Those are actually TW Profile traces, and you can download them if you want and use things like Purview, WPA, or Visual Studio to open and dive deeper into them. But we give you actually a very rich cold stack view with a hot path auto-expanded right inside the browser. So many times you don't need to go and download and open this in a different tool. So in this case, I'm seeing if I collapse this, that most of my activity was spent in Azure Blob. 443 milliseconds was waiting on Azure Blob storage activities. And then another 402 milliseconds were spent waiting on Azure Queue activities, and that's where my hot path is. And then I also spent a bit of time on SQL. There is also some time spent here in my actual code, I believe. Yes, this is the actual code that I did in my code. But most of this was slow because of the dependencies. And as I expand these, I can see individual dependencies. And this is amazing. Being able to see from production without production impact, individual calls. So I know that set permission spent 170 milliseconds. And I know that in this case, upload text spent 112 milliseconds. Right? So there are multiple causes, all combined into a single intermediate cause of Azure Blob activities. And then you have multiple intermediate causes all together impacting your duration to be as slow as it is. Now, get home index should not take 1.5 seconds. And if you dig deeper into this data, you will see even cases where it takes much longer than that. And this is usually because of dependencies. I mean, remember, cloud experiences that have dependencies can experience slowdowns. So it's important not to block the user experience on that. Switching between this on the left, you can look at different examples of this. And this will let you go and double check that, yes, this is exactly the same problem across multiple instances and not just a one-off. And all of this has been collected for you ahead of time. You don't have to do any work. I used to do performance work for Power BI, and we used to collect these things by hand. And when you have an LSI sitting with a console trying to get this by hand, using a tool like WPR is very, very hard. So this is really awesome. Notice that you can do 30 days here, last 30 days, but in fact, you can actually jump even more back. There is up to 90 days of retention data by default that you can jump back to. Also notice that in addition to time range, you can select multiple different roles. And while this application is a single role, I'll show you afterwards a couple of applications with more than one role. You can change your scale between linear and logarithmic. And the reason that's important is that sometimes you have a really long tail and you don't want that long tail to impact the shape of your distribution. So when you switch to this linear, we actually cut off a 99th percentile. We don't show you the things that are the long tail, the sort of the outliers that typically don't bring back good value on your ROI. And then also notice that you can go and contrast to your operation trend secondary counters, like your request count, and that's basically your load on the service, and the CPU on the machine, or on multiple nodes if you are actually integrating across two instances like here. Memory, storage. Now I'm doing this across 3 days, but I could easily do this across 7 days, or even 30 days. And since we have a really powerful big data engine behind the back on Application Insights, the backend is able to quickly go and fetch us all of this data. Very, very responsive. Of course, as your number of samples grows, so will the distribution become prettier and sort of more normalized. And in this case, you will see that reports index has really, really nice experience at 2.4 milliseconds, and okay experience at 4.5, and then slow, some might say, for 10. 10 milliseconds is still pretty good. But in this case, this is a clear issue. You have a good experience at 1/3 of a second, and then you have a couple of bad experience at almost a second, and then 1.1 seconds. This is where I would actually spend time understanding what's going on and drilling into this data set. Remember I told you that it's now much easier to get to the individual request details without leaving this view? Let's actually take you through that experience. For that, I'm going to go to a smaller date range, so you don't have to look at so much data. So last 24 hours, there were 714 samples within this data set. Let's drill some more. So I look at some of the spikes, and in this case, there are only 8 samples here. And if I zoom out, I'll see the result of 72. So I'll zoom in around this particular range. Now there's about 54. If I click on this button, it will open up in place, no separate blades required, the list of just the samples specific to what I've sorted on and filtered to. Right? And clicking on any one of these, I'll be able to see the details blade right for it. Now this is very, very interactive. And as I continue to drill here and switch here, for instance, if I zoom on just this list changes. And these filters at the top get updated interactively, which is really, really cool. This lets you very quickly jump to the right request and see all the details about it, including the timeline, without ever leaving your triage view. Great, so now that we've seen a demo of APM v2, let's actually look at the comparison of v1 to v2, so you see just all of the sort of the key points that we brought to you with this improvement. v1, we used to show lots of data. In v2, as I said, it's now all insights and then data to back it up. v1, it was a blade fatigue experience, sometimes up to 5 blades deep, and in v2, we have a single full-screen interactive view for all of your triage needs. V1 gave you a very long list about a couple of blades in to search through the requests and go and find your requests of interest. In V2, we give you a nice visual chart at the top right corner to see how often slow requests happen, so you can zoom in on just the slow ones very quickly. In V1, the integration with Service Profiler was basically a link to different service, while in V2, it's built right into the tool, and you get the custom deep integration experience whenever you filter and then click on the Profiler Traces button. V1 wasn't particularly fast, and that was largely because of the open-endedness of this experience. We could do pretty much anything, any data, any way filtered and shaped. And in V2, we really made it more curated, but that made it possible for us to pre-compute much of this, so it's very responsive. I'm a performance guy by nature, and I really enjoy using the API in V2, while V1 was a pain. V1 was a single role web app experience, and what I mean by this is that it was primarily designed to be an APM for an ASP.NET app, right? And that's a single role application in the cloud, or on-prem on a server, which we also actually support. V2 can do multiple roles, and this is adjusting to this new universe of multiple role microservices architectures, where you can't really just debug a single app in isolation, and you can't afford to have different AI resources. You want them all together and then be able to slice and dice on your data within it, because possibly the same dependency is impacting multiple roles. We also had complex filtering because of the open-endedness, and you can filter on anything you want. And now the filtering has been much simplified. You still get all the previous filtering. If you really need to, just go to metric exploration and the analytics. But for the typical triage experience, the 95% workflow, it is now much easier to go and get through the filtering. Like I mentioned, it was open-ended and now it's tailored and curated. You can now pick any specific operation or operations and contrast them side by side you want through pinning. You can sort however you want. We give you spark lines, whether it's by duration of whatever percentile you choose, or if it's, say, count of usage. Speaking of percentiles, you get to choose, depending on the maturity of your business, whether you want to work with averages, medians, 95th or 99th percentiles. And as the service matures, you really want to strive towards the 99th percentile, which means 1 out of 100 fails. And of course, the distribution is the ultimate KPI to quickly at a glance see just how many issues you experience or your users experience for a given operation, and you now have this at your fingertips. There are some other cool things I'd like to explore with you in this video, and I don't have too much time, so we're only going to touch on them. Analytics integration is important for you to know about. There are more insights than what I've shown you so far. There are smart detection insights that can detect regressions over time. You can have also view into dependencies, irrespective of the operations. That can be a very valuable tool to go and see whether a SQL dependency went down or a blob storage dependency slowed down and that impacted your experiences. And then looking at the browser side, not just the server side, there is also the client-side performance investigation blade that I'd like to show you. So let's jump into the demo. So now let's take a look at a more realistic demo. This is an actual backend service. It's one of the pieces in this big thing that's called Application Insights that's running in Azure. And we actually monitor Application Insights using Application Insights. I'm going to go and try to do some performance investigations here. Notice how responsive this UX remains, even though I now have about 19 million requests overall that I'm looking at. And let's actually go and expand to 30 days, because I want to see the trend over time. And note this new insight card that showed up. I haven't seen this before in the previous small demo app. What this is it's telling me that there is a regression somewhere here. And in fact, the regression is in get health status, and it is 13x slower. Actually, no, it's 135x slower. This is 13,000 slower. And it used to be almost 0 seconds and became 246 milliseconds, which could add up to be a big issue. You wouldn't find this unless you had an insight, right? You could be just clicking. I could be doing this. So the way you do this is you go to overall, and then you click on this insight, and it will auto-scroll to just the right operation. Imagine having to find this yourself. And right away you go and you see that you had a really great experience of 2 milliseconds to get health status, and all of a sudden it slowed down. So it's some internal performance issue that could be impacting our service, right? Maybe in this case the user is not impacted, maybe he is. We would have to go and investigate. You also see right in the distribution duration chart that there is a spike around the 99th percentile, and that's contributing to this increase. The Smart Detection Insights are a really powerful feature to help you find that needle in the haystack. And there is actually more integration in here. If you click on the ... the more menu, and the view details, you can dive into the smart detection blade that previously was a separate experience and now is again deeply integrated in APM. And you can see both your average and the percentile as they ramp up to become slower. You can see whether the load impact was related, in this case no, so it's likely a dependency. And I'm not going to diagnose this production issue, it's an LSI, but you can see how quickly you went and found a new issue using Smart Detection Insights. Another really cool and important feature you need to be aware of is the view and analytics. This is the integration with our great Custo query language, the backend that powers all of this user experience. So here you can choose which one you want to actually go and open up in Custo, and I can go and say, for instance, show me the performance histogram. And what that will do is it will open up the analytics, the application analytics view, and it will actually pre-populate the query that powers that distribution chart for you. So here it is, and this looks exactly like what we saw before. So if you want to explore analytics and dive deeper and filter by more items, you can always do something like this. Request count. Boom, and it's going to show you that particular trend. This is a great way to explore how to author your own analytics queries if you need to go to that level of detail. Another really powerful feature that I haven't shown you before is the dependencies tab. So let's move back to our ASP.NET application and say, let's look at the last 7 days. What I can do is I can actually switch to the dependencies tab and not look at operations of my service, but rather the dependency calls that it's making. And just like operations, these are the outbound calls made to SQL, HTTP, Azure tables. If I want to say care about SQL, I can always type SQL and see just the SQL ones. I can sort them again and look at the dominant activities. And I can see that there are some really great ones and some not so great ones. But in this case, it's all pretty fast. So let's actually go and find some slow ones. This service is actually pretty good as far as dependencies, but here are a few slow ones. 5 seconds, 476 times. And you can see that all of them were the same exact thing. Now that tells me that it's probably a timeout. And if I dive deeper into this, I will likely find this to be a timeout. Let's actually check. I'll click on samples. I'll see that all of them are 5 seconds. They're all trying to connect to the same exact data warehouse. In clicking on any of them, I will find that yes, this is a timeout expired. So this is a very quick validation that I have a responsiveness issue in one of the dependencies because it's failing. The final feature I want to show you is that of client-side performance management. Now, we haven't yet brought that from the V1 to the V2 world, and it's still a bladed experience, but it's something you may need in your investigations. So clicking on the browser's menu option, you will see a list of graphs that tells you whether your pages were slow, whether it's because of AJAX calls, and whether it was caused by traffic. Clicking on these views will take you to second-level views. So this still suffers from some of the blade fatigue that we have fixed for the server performance management, and we are going to improve on that in future releases of Application Insights. But this is something to be aware of if you need to look at what the browser experience was like. So now that we've seen this in action and went over the biggest improvements, let's review some of the calls to actions for the session. First, I'd like you to go and try this out yourself. I've shown you enough, but until you try, you don't really know how to use this. So go and take this opportunity to investigate the performance of your own web application in Azure. And then make sure to enable a profiler. It is disabled by default, but it's really worthwhile enabling because without it, all you'll get is the triage view, and you really want to be able to dive deeper and diagnose your application. We also put together a quick start guide so you can go and review in more detail how to use all of the features I've mentioned in this talk. And then please review the auto-generated insights. We spend a lot of time and man-hours building these insights so that they can help you guide your triage and your investigations to the right places. And we want your feedback. In fact, we want it so much that we build a feedback button right into the APM. And there are 3 options in there. Suggest an idea, will take you to our user voice. And then you can send us a smile or a frown with some comments. And all of this telemetry goes straight to our product team, and we review this in a daily stand-up. So please give us your feedback. You can also check out related video on failure investigations. APM isn't just about performance and slowdowns, it's also about things failing. And we used exactly the same approach of full screen interactive experience to help diagnose failures. Dan Taylor recorded a great session of how that integrates with snapshot debugging, which is just like Profiler but for failures. There's also opportunity for you to reconnect on Channel 9 and look at more sessions on the Microsoft Virtual Academy online. I'd like to conclude by saying that when we were building Windows 7, making it much faster than Windows Vista, you all know about that story. If we had a tool like this, it would save us many years in the process. So go and check it out on your own application and make Windows Azure application as fast as you can for yourself. Thank you.